Okay, so let me say this again. So basic log properties. So we're talking about logarithms or logarithmic functions. So you can't take the log of a number that is 0 or less. Okay. Now that doesn't mean that I can't have a problem that looks like this. So log base 3 of negative x. That's not saying that. What that means is the inputs that you plug in, because remember, when you got something like x there, you get to choose what numbers get put in there. And but even though you get to choose, there are often restrictions. Okay? There are often restrictions. So because there are restrictions, right? In this case, because my my x here in this is negative, I can plug in negative numbers. That's perfectly acceptable, you know. But the result, right, is what I'm talking about. So when I'm looking at the parentheses, the x's that I put in here, they can't result in something that is less than 0. I can't have that result. I can't have a negative number in there, and I can't have 0 in there. Now, if you need me to explain why you can't have 0 in there, let's just think about what logs mean. Let's just talk about, how about let's just say b. So we're talking general. So log b of x equals y, right? If I change this, because this is logarithmic form, that's logarithmic form. The exponential form is b to the y power equals x. So in this case, I'm talking about b to some power is going to equal, is going to equal 0. There's no number and no power that I can plug in that's going to give me 0. All right, there's no power and no number that I can take to a power that's going to give me 0. So that's why I can't have 0 here. I hope that isn't confusing. That these two things, these are like two sides of the same coin, right? Two sides of the same coin. Okay. And so with this thing going on like that, why can't I plug 0 or a number lower in here? Because I don't get to have a number and take it to an exponent and get 0. I can't do that. Okay. So that has me going back to this. So like I said, that doesn't mean that x can't be less than 0 or can't be negative. When you're choosing your numbers, it's just the result of what's in those parentheses can't be 0 or negative. That's what I'm saying. So focus on if you got an expression that this is all a little extra stuff that there is. There could be a number that's in front of your logs, and you got your base, and then you could have a number that's being multiplied by this, and then you got the number that's outside of there. This part right here, the part that you're taking the log of, that part has to be bigger than 0. It's just, that's the way it is. The result, yes. Running what? Both of these? Yeah, but I started on it this morning. So I'm talking about this, and then I'm gonna get to this. So but yeah. So anyway, um this is just general stuff that I need you to understand so we can talk about this. Okay? That's what I'm doing. So like on your review, we've got problems that you're given a logarithmic function, or a logarithmic equation, if you want to call it that, and you're asked to find the vertical asymptote, the domain, and the x-intercept for the logarithmic functions. So for the domain, if you want to find the domain, what you need to do is you need to take the parentheses part of your log and set it to greater than 0. So what the heck do I mean? Well, let's do an example. So let's say log of 2, or log base 2 of, how about we say 2x minus 6. you know, a plus 5. Don't even matter. Now, what I'm saying to you is that for this, the important part is this right here. This is the important part. Okay? Even though I got this log problem and all this blah blah blah, like what's the base? And I got this number 5 here. When I'm talking about domain, the only part I really care about is the part that's in the parentheses. So I take that part, 2x minus 6, and I set it to is greater than 0. And then I solve this. Okay? Guess I need to write that up there too. And then solve. Now, when I tell you to solve something like that, that means you isolate your variable. So in this case, most of the times it's going to be x, but I just want to say variable just in case it's not x sometimes. That doesn't matter. Okay, so anyway, I'm going to solve this. When you have, this is called an inequality because it's not saying something is equal to something. It's saying that something has to be, it gives you a range of values that it can be equal to. So it gives you like a restriction on a value. So, but I treat it like an equal sign when I solve. So what am I going to do? I'm by adding 6 to both sides. And so I got 2x is greater than 6. And then I do what the next step would be. I need to isolate x by getting rid of this 2. That's 2 times x. So I'm going to divide by 2 on both sides. And dividing by 2 here, that goes away and I got x. And then I got greater than, and then I've got 6 divided by 2, that's 3. So x, it has to be greater than 3. That's what the restriction is for this. Now, domain. Domain is just the group of numbers that you get to pick from to plug in your variable. To plug in your variable. I don't want to keep saying x because, like I said, it can be any number. But just for intensive purposes for this, I'm just going to say x. So for the numbers that I get to plug in x, they have to be bigger than 3. If I plug in a number that's smaller than 3, either I get 0 or I get a number that's negative, and that gives me a problem. So I can't have those numbers like that. So this is my domain. X has to be greater than 3. Okay? You can also use set notation and say 3 comma infinity. Now, what ends up happening is if you see small brackets like that, it means that you can't use the number there. Okay? That's what that means. Like if I gave you this, if I gave you a bracket like solid like that and said infinity, what that means is that you can use 3, but in this case you can't. So I don't. You know what? Let's erase that because I don't want to confuse you. Let's not talk about all that. So these are the 2 ways that are acceptable if I'm asking you about domain. Okay? Or you could say something about all real numbers greater than 3. All 3 of those will be acceptable if I ask you about domain. Okay? Domain is the group of numbers that we're talking about. And that's 3 different ways to describe the group of numbers that we're talking about. Okay? All right? That's domain. That's how we find domain. Okay? That's how we find domain. So then, let's go. Find vertical asymptote domain and x-intercept for a logarithmic function. I'm writing it. You do you. You write it however you need to write it. Okay. I'm just I'm doing sort of like a form. So I'm still saying the same thing, and I didn't have enough room to write this on one sheet. So that's that. So next, I want to get the vertical asymptote. So I take the parentheses and set it to equal 0 and then solve it. So let's give another example. How about we say log base 4 uh, let's do 2. So how about we just give something simple? X minus 3 plus 2. So I would take the parentheses part, right? And so I'll take x minus 3 and set it equal to 0. And so then I will add 3 to both sides, and I will get x equals positive 3. That is my vertical asymptote. Now, just so we're clear on what a vertical asymptote is, come on, I got stuff to do, hurry up. Okay, log of 4 x minus 3 plus 2. Okay, so let's do this. So equals, say log base 4 of x minus 3, say plus 2, I think it was. And then we said x equals 3. Move this out the way. Move this over just a bit. Actually, no, let's not do that. Let's do this. Okay, so let's look. That red curve right there, that red whatever you want to call it, that's my graph for the log of y equals log base 4 of x minus 3 plus 2. But the vertical asymptote line is x equals 3. That's that blue line that's right there. In fact, let's not do that. Let's do this. There we go. That green line is my vertical asymptote. And all a asymptote line is, it's like a guideline for when you're graphing. Okay? So if you look, even though when we just looked at that graph, it looks like the red line and the green line overlap because it's so small to us. But bottom line is, if I zoom in, I can see that those lines never touch. And obviously I'd have to keep messing around and going lower and lower. But if I just keep magnifying it, they never touch. And that's what an asymptote line is. It's a guideline. It's like it's the MC Hammer of uh of math, because you can't touch it, you know. Not that y'all will get that joke, but that's Okay, you kind of mess up the joke when you explain it, so thanks for just messing it up. But anyway, I'm just messing with you, bro. But yes, that's what I'm saying. And see, the closer I get, it's never gonna touch it. Okay. Now, obviously, when we're drawing graphs, I'm not gonna make a big deal if it touches it. But the whole point is, an asymptote line is a guideline for your graph that your graph is not gonna touch. Okay. Okay. So that's that. Let me just give you another example. Say let's log base 5 of 3x plus 8. And we don't even have to have anything else there. So I'm going to say 3x plus 8 equals 0. And then I'm going to solve that. So I'm going to subtract 8 from both sides. And I'm going to get 3x equals a negative 8. Then I'm going to divide both sides by 3. And so I get x equals negative 8 over 3. Now, negative 8 over 3 is not something nice. It's not cute at all. It's definitely not cute. Let's just cheat a little bit. All right. Say what? 3x and 8. And then let's say x equals negative, I'm going to say 8 over 3. Okay. Yes, ma'am. Say it again. It's plus 8. Thank you. All right. And then let me, and then get rid of this and get rid of that. And let's talk about what we see. Whoop. Talk about what we see here. Okay. I don't want to go 2 point. Well, yeah, I got to go 2.5 because that's negative 3 over 8. So if I look at this graph, see here is my 0, 0 line. And this thing is over in the negative spot. In fact, I needed to go in halves, 0.5 units as opposed to just going ones because this thing is in between, in between like 2 and 2.5. That's what this line is at. Let me see if I can make that a little. Okay. Let me see, maybe one more time. Yep, there we go. So negative 8.3 is between negative 2.6 and negative 2.7. So that's where my line is right there. That's my asymptote line. And here's my little funky graph. So you can have an asymptote line that's negative. And now let's go back to generally how it looks. Something like that. Asymptote lines. They kind of make it to where you can see what's going on. All right. So that's how we figure out asymptote lines. So we got the domain and asymptote lines. So now we can do the last one. Say it again. I didn't hear you. I need to do the last one. So find the vertical asymptote, domain, and x-intercept for a logarithmic. Finding the x-intercept, I think, might be the most intense one. Oops, function. All right, so now let's take a couple. So x-intercept is what I'm doing. So what is the x-intercept? Well, the x-intercept is the point on your graph or points on your graph where your graph intercepts the x-axis. So right here, I'm looking at this and we're talking about the graph that we just did. The x-intercept for this graph is this point right there, because that line that's going across horizontally is the x-axis. But that point right there, that point is where my graph, intercepts the x-axis, where it touches it. Now, see, you can have graphs that have more than one intercept, or you can have graphs that don't have any intercept, that are a certain way that they don't touch the x or y axis. So you got x-intercepts or y-intercepts, but right now we're just focusing on x. So when we're talking about a graph that looks like this, right? This right here, this line, that is the y-axis, and this line is the x-axis. X-axis, y-axis. So when I'm looking for the x-intercept, I'm looking for the point or points on my graph that intersect or intercept or connect or touch the blue line in this case. So like if I drew that one right here, my x-intercept is 3 point blah zeta blah and 0. So that is the point. Now see, the thing about the x-intercept is y always equals 0. That's the thing, is y always equals 0. Okay? Because it has to touch this line, and if y doesn't equal 0, then it's up here or down there somewhere. In order for it to be a x-intercept, y needs to equal 0. So that's how we solve our stuff. Okay, that's how we figure out what we're doing. So the x-intercept, I need to set y or f of x, depending on your notation, to 0. Or better yet, let me not say set. Let me say it a different way. Let's say replace. So I replace y or f of x with 0, and then solve for my variable. Well, yeah, I'm just going to say solve for x because it's called the x-intercept for a reason. So let's just get it right. So solve for x, right? Okay. So let's look at a couple examples that we already did, right? So let's start with log base 4 of x minus 3 plus 2. So y equals that. So what we're going to do is replace y with 0. So we're going to have log base 4 of x minus 3 plus 2. And so now we're going to solve that. So the first thing we're going to do after we change that to a 0 is we need to get the log by itself. So I'm going to get rid of this 2. So I'm going to subtract 2 from both sides. So now I have negative 2 equals log base 4 of x minus 3. Now, this is where I'm going to say this weird word, and I hope I'm spelling it right. Exponentiate. And I'll explain what that means in a second. So this is where I am right now. I got to deal with this. The way I need to get to that x, But see, the x is part of this log. So I need to get around that log. So the way I'm going to get around that log is by using this rule that we did some time ago. That if we have log of some base of x, if we exponentiate, which means we take and make it an exponent, what ends up happening is that this part and this part cancel each other out, and all I'm left with is what I'm taking the log of, the x. Now that sounds complicated and it looks complicated, but it's not. For instance, if I said I've got log base 5 of x minus 1, right? And I need to get to that x. What I'm going to do is take both sides of my equation. Well, let me do something. 0. So I'm going to take both sides of my equation and exponentiate. So I'm going to make both sides an exponent of 5. So then that's going to be 5 over here to the 0. And then I'm going to have log base 5 of x minus 1. And so what ends up happening is I'm going to ignore the left side for a minute and just talk about this. Because, see, I get to choose what operations I do when I have an equation. So I'm choosing to exponentiate, to make both sides an exponent of 5. I chose that. And when I do that, this 5 and this log of 5, not the whole thing. Okay, let's see if I can do that right this time. Just this part, right? Those two things, they cancel each other out. So then all I'm left with is x minus 1 on the right side. Now over here, what is 5 to the 0 power? Anything to the 0 power is 1. So I have this equation. And now it's easy to solve, right? All I do is isolate x, and then I get my answer. That's what I'm doing over here. It's the same principle. I'd add 1 to both sides, and I'd get 2 equals x, or x equals 2. Now this was just an example, a more general example. Now let's do the specific one. So I started by replacing y with 0, and then I need to get the log by itself. So I subtracted 2 on both sides. Okay, and then when I did that, what I ended up getting was to here. I need to get rid of this log base 4. So I'm going to exponentiate with 4. So I'm going to make my two sides of my equation exponents of 4. X minus 3. So now that I did that, I've got I got 4 to the negative 2. Well, I have to take that. Well, I know that 4 to the second power is 16. But 4 to the negative second power is what? It's 1 over 16. Remember, negative exponents, because we have to change them positive. When we change them positive, it changes position of what I have. So this 4 becomes 1 over 4. And then I take that to the second power. And that to the second power is 1 over 16. Where? The log of 4. Okay, so when I take log base 4 and I'm making an exponent of 4, the 4 here and this log base 4, they cancel each other out. So all I'm left with is x minus 3. And now I can solve that. Now it's not cute because I'm dealing with fractions, but I can solve that. So I'm going to add 3 to both sides. Now when I do something like this, I need to change that 3 to a fraction. So I got 1 over 16 plus, and then let's just do it to the side here. I need to take 3 and change it to where it's got 16 on the bottom. So I'll multiply 1 times 16, and I need to multiply the top times 16. So 3 times 16 is 48. So it's 48 over 16. So I'm going to have 1 over 16 plus 48 over 16 equals x. So my x is going to equal 49 over 16. You can't reduce it, and that's how it looks. Not all that cute, but that's the answer to the problem. 48 plus 1, man. There's 1 over 16 right here, and then there's plus 48 over 16, because I said it's 1 over 16 plus 3. That's a little funky, right? So I change it to where it's got a denominator of 16, find a common denominator, then I can add the things. You got what I'm saying? All right, I'd like to do maybe another example of this because I think that one's the most challenging. So, x-intercept. I'm gonna do set y. No, I'll replace. I can be saying set. Replace y or f of x with 0. And solve for x. So let's go with f of x equals, say, log base 2. See something that's a little nicer. 5x minus 19. Yeah, let's just leave it like that. So what do I need to do? I need to, first, I replace my f of x with 0. Then I exponentiate. I need to take these and make them exponents of this number of 2. So 2 to the 0 power equals 2 to the log base 2 of 5x minus 19. That's not a good looking 19. So doing this, well, 1, 2 to the 0 power is 1. Anything to the 0 power is 1, right? But over here, I've got 2 and I've got log base 2. Those two things cancel each other out, and I'm left with 5x minus 19. And then I just solve. So I'm going to add 19 to both sides. And that's 20 equals 5x. Well, I can solve that. So I'm going to divide by 5 on both sides, right? The 5's cancel off. That's 4 equals x. So that's my x-intercept. To be on the safe side, another way to write that is when y equals 0. So it would be a coordinate that looks like this. I would write my x here, and I would write y as 0. So I would accept either of these answers.